Today, we're opening up a really powerful toolkit. It's one that's designed to help you find clear answers in a pretty complicated world. We're talking about the fundamentals of statistics.
So, let's start with the big question you see here. How do you actually make smart, effective decisions when you're just drowning in information? Well, the answer lies in statistics. And over the next few minutes, we're going to explore what statistics really is, we'll look at its single most important concept, and then we'll unpack the two main tools you'll be using to make sense of it all.
All right, let's dive right in. To get started, we really need to get a clear handle on what we even mean when we say the word statistics. Because, it's a lot more than just a bunch of numbers and charts.
At its heart, this is really what it's all about. Statistics is a process. It's a systematic way to take all this raw information, that's the collecting part, and then shape it into something we can actually understand, that's the organizing and presenting. And then you dig into it to find the real meaning, that's the analyzing and interpreting part. And the whole point of all of this? It's just to help us all make better, more informed decisions. Simple as that.
Now, if you only remember one thing from this explainer, please make it this next concept. It is the absolute foundation of pretty much everything else in statistics. Think about it like this. You don't need to drink an entire pot of soup to know if it needs more salt, right? You just taste one spoonful.
That whole pot of soup? Well, that's what statisticians call the population. It's the entire group we're interested in. And that one spoonful, that's our sample, a small, manageable piece of that population that we can actually examine. We study the part to understand the whole. That really is the big idea. And you see this everywhere in the real world. For example, the population could be all the likely voters in an election. I mean, that's millions of people. There's no way you can talk to every single one of them. So what do? We take a sample, maybe 1,000 voters, to get a pretty good idea of what the entire population is thinking. Or, let's say a factory makes thousands of parts a day. They can't test every single one, especially if testing it means destroying it. So they take a sample, just a few parts, to check the quality of that entire day's production run. And this visual? It's a perfect way to picture this idea. Imagine the entire alphabet is our population. We might not be able to see every single letter, but just by looking at this small sample, we get a fantastic snapshot of what the whole thing is made of. The sample represents the population. So once we've got our sample, what do we do with it? Well, this is where we get to open up that statistician's toolkit we talked about. And inside there are two main power tools that help us work with all the data we've just collected. Okay, so the first tool is called descriptive statistics. This is all about describing the sample that's right in front of you. The second tool is inferential statistics. Now, this is where things get really interesting. This is where we make an educated guess, or what's called an inference, about the entire population, all based on our small sample. So think of it this way. One is about what you know for sure, and the other is about what you can logically deduce.
Let's take a closer look at descriptive statistics. It's actually a really straightforward, logical process. First, you collect the data. Maybe you run a survey or make some observations. Second, you present that data in a way that's super easy to understand, like a simple chart or a graph. And third, you characterize it, usually with a summary number, like calculating the average, which is also called the sample mean. You're simply describing what you see.
This slide right here really captures the magic of inferential statistics. We have information from this small group of people. That's our sample. And inferential statistics gives us the power, the methods, to use what we know about them to make a really strong data-backed statement about the entire population. It's how we go from tasting that one spoonful of soup to understanding what the entire pot tastes like.
Of course, all these tools, they need something to work on, right? They need raw material. And in statistics, that raw material is data. And, just like a carpenter would use different tools for wood than for metal, statisticians have different ways of handling different types of data.
So the first big split is between qualitative and quantitative data. And as you can see, qualitative data, which is also called categorical data, it just describes a characteristic. Think about things like marital status or eye color. You fit into a category. Quantitative data, on the other hand, is all about numbers. Anything that you can count or measure, like your weight or the number of kids you have.
Now, we can break that quantitative data down even further. So on one side, you have discrete data. These are items that are counted in whole numbers. For example, the number of bedrooms in a house. It can be 2 or it can be 3, but it can't be 2.75, right? There are these clear gaps between the values. On the other side, you have continuous data, which is measured. It can be any value within a range.
Think about the weight of a pork chop. It could be 250 grams or 250.1 or even 250.11 grams. It all just depends on how precisely you measure it.
So, let's bring it all home. We've defined what statistics is. We've seen how we can use a small sample to understand a much larger population. And we've just opened up the toolkit to see the main tools and the raw data you'll be working with. We've essentially just handed you the keys to a really powerful way of understanding the world. So the only question left is the one right here on the screen. Now that you have the tools, what questions will you answer?